Hi everybody, welcome to the CS381 virtual reality tutorial. First I'm going to talk about how to set up a Unity project to work with an Oculus VR headset. Then I'm going to talk about some further steps for setting up the scene to work better with virtual reality, and including some development tips and solutions to common problems. This document is available that lists all the steps, and there should be a link in the description of this video. So the first thing we're going to need to do is set up the Oculus device. If you've never used an Oculus device with your computer, you're going to have to go to the official Oculus setup page, and it'll have a link to download the software based on which headset you're using. And once you download the software, it'll have steps for calibration and setting up your sensors and everything you need to know. Next, we're going to talk about setting up the project for Oculus support, and we're going to start with installing the Oculus integration package. So I'm working from the solution to assignment 5. If you want to follow along with the same solution, that's a good idea, but the steps should be exactly the same for your own project as well. So first I'm going to go to the asset store, and then I'm going to search for Oculus integration. And I want to make sure I download the one that's released by Oculus, so it's the official Oculus integration package. So I'm just going to click import and wait for everything to import. This could take a few minutes. Once that's done, you should see this window come up. We want to make sure that all the boxes are checked by clicking all, and then click import. Then we're going to wait again for a couple minutes until everything is imported into the project. Once that's finished, you should see the project will ask you if you want to upgrade to the new spatializer plugin. Any plugins that ask you to upgrade, you want to click yes. Now it's going to tell you that you're going to have to restart the Unity editor. So we'll click restart. It'll ask you about an OVR plugin. We want to upgrade that as well. So click yes. And then once that loads, it's going to give you the option to restart. So we're going to click restart. Okay, so now we're back in our project. We should see that in our project folder under assets, we have a new folder called Oculus. This includes all the assets and scripts that you're going to need to use the Oculus headset in your game. First, we're going to talk about how to set up the OVR player controller. The OVR player controller tracks all the player tracking, so the tracking of the headset, the tracking of the remotes. It also includes scripts for handling input and things like models for the hands, so you can see your hands when you're in the scene. Pretty much everything that you need on the most basic level for a VR game is in this folder. So first, in the OVR player controller. So first we're going to search for OVR player controller and find this prefab, and we're going to just drag this into our scene. And we're probably going to have to wait for some scripts to compile since we just imported the package. Now under the OVR player controller, we're going to look under the OVR camera rig and find the tracking space object. Then back up in our project tab, we're going to search for local avatar and find this prefab. We're going to drag the prefab so that's a child of the tracking space object. Now we should see the children of the tracking space object include these anchors and also the local avatar. Once you've done this, your scene should be ready, so when you press play, it'll automatically launch the Oculus software, and when you put it'll automatically turn the headset on, so you can put the headset on and you'll see your scene. So this finishes the steps to get the project set up to work with Oculus. Now we're going to talk about some common tips and solutions to common problems for development that you may encounter. The first one is if I press play, our player, first of all, my headset isn't on, so the view will continue to just show straight ahead, and my player is falling through the floor. So we want to make sure there's a floor collider for our player to stand on. Your game may already have one depending on your environment, or it may not. So if I'm going to create in the scene an empty object, I'm going to call this floor. I'm going to reset it to position 0, 0, 0, and I'm going to add a component of a mesh collider. Now in the mesh field of the mesh collider, I'm going to click on this little circle, and I'm going to search for the mesh called plane, and assign that. So now in our scene, if I look at 0, 0, 0, I should be able to see this green box, this green kind of grid here, and that's the collider, the mesh collider on the floor plane. You can't see this in the game view because we didn't put a mesh renderer on it. It's just there as a collider. Now we want our player to stand on this, so it's looking pretty small right now, so we're going to scale this to be 100 by 100. So our player has now plenty of room on this large green grid to be able to stand in the scene. Next, we want to click on our OVR player controller, and we're going to zoom back in, and we should see that, if I can find the collider here. The collider here is overlapping with the point point 0 on the y-axis, which means that it may still fall through the floor since it's currently colliding with our plane. So we're just going to reposition this to 1 because that's the player height. Now if we press play, the view will still continue straight ahead because I don't have my headset on, but the player will now not fall through the floor. Now next, we're going to want the player to be able to see the ships and give commands to work with the assignment 5. So we're going to want them to be a lot larger than this. So we're going to go ahead and scale them up to be 50 meters tall. Now you may notice that again the player is intersecting with our floor plane, so we're going to want to reposition it to be at the point 50 on the y-axis. And now we should see that the player will be standing right on top of this level 0, 0, 0 and on top of the plane, so it won't fall through. Now the problem is, since we scaled our height up to 50, the collider is now very skinny, so if your game has any collisions with the player, they won't work correctly because they will only collide when it hits right in the center. So this is why we want to make sure that the scale of the player is the same in all directions. So 50 by 50 by 50, and we want to keep all these dimensions the same so our collider has the right dimensions. If you want to adjust your player collider to be different sizes, you can change the center here in the character controller. You can change the radius and change the height. That's where you want to control the collider size, not by changing the scale. Now I'm going to reposition the player to be back a little bit so he can see the ships better. And if I press play, since my headset isn't on, the view, it'll think the camera is down on the floor. But if I were to drag the camera, the tracking space up, as this is to simulate my headset being on, now my view will be up much higher because I'm 50 meters tall. I'll be able to look around the scene and see everything that's going on and not fall through the floor. So next we're going to talk about adjusting the player controller. So you may notice by default the player, when you're in the scene in VR, is able to rotate the player controller with one of the joysticks and move around the scene with the other joystick. Depending on what your game is, you may not want the player to have the ability to move around the scene and to rotate around the scene without moving around in the real world. So to fix this, we're going to look at the OVR player controller object. We're going to look at the OVR player controller script, and we're just going to enable linear movement and enable rotation. Once we've done this, the player won't be able to move around without moving around in the real world, won't be able to rotate without turning their head, which for the majority of VR games is the desired behavior. It's important you don't disable this component or remove this script from the scene, because otherwise this script is responsible for a lot of the player tracking and other important features that you're going to need for your game. Next, we're going to talk about a spectator camera. So if you have other people trying to spectate your VR game, it can be difficult to see what's going on because your computer monitor will be showing this game view here, which is showing whatever the player sees, which can be shaky and zoomed in and be hard to follow. Also, for this class, you're going to have to make video demos of your gameplay, and the demo won't be good enough if all we see is a shaky, zoomed in view from the player's perspective. So to fix this, we're going to add a spectator camera. So the first thing we're going to do is add a new camera to the scene. This may cause it so when you press play, you get a warning that there's multiple audio listeners in the scene. So we're just going to disable the audio listener on our new camera because we're not going to need it. Then we're going to set the target display, the target eye to none or main display, so that instead of trying to render this camera to the view of the player, it'll try to render it to just the main display. Then we're going to set the depth to 1. The depth controls the order in which the cameras are rendered and makes sure that this main display has this view rendered first. Now I'm just going to reposition this camera in our scene to somewhere where I can see the ships a little better and see the player and the gameplay. Oops, just got to move the wrong thing. Let me move this up a little higher to the side, rotate it so it's in a good view to observe everything that's going on. Now since we changed our target eye and our depth, if we press play, our game view here in the editor will continue to show this camera's view. If I turn on gizmos, you should be able to see where the player controller is at, and the player will be able to move around the scene. It will, in the headset, they will still see their perspective just like before, except the display will show this view. Also, when you build your game, your monitor will be showing this view, which will allow you to position this camera so you can see the gameplay and screen record and use that for demos in the class. And also, if you're ever playing your game and other people are spectating, they'll be able to see what's going on a little easier. You can also parent this camera to the player controller and move it back a little bit so that it's always facing the forward direction of the player. It kind of just depends on what your game concept is. So next we're going to talk about input with the Oculus remotes. So input with the Oculus remotes, the programming will be similar to how we've done input so far in the Unity assignments. You'll see that instead of input, we're using OVR input, which is included in the package that we installed. So we're going to have things like OVR button, OVR touch, OVR input touch to access the different buttons and axes of the controllers. This website also includes examples on code. So you see OVR input.get, .get down, .get up. These work in the same way as get key down, get key up that we've been using in our assignments. And you'll see that there's also different names for the buttons. And if you scroll down further, there's diagrams for where button 1 is, button 2, which trigger is which, and then naming. And a link to this website is included in our VR tutorial document here. So this is going to be your best resource for how to handle input. Now it's important to remember that when a player is in VR, they're not going to have access or be able to see the keyboard or mouse. So you need all of your game to be controllable from the controllers. Now this includes UI, which can complicate things a little bit. So it's possible to use the controller joysticks and buttons to navigate between the selected buttons, much like if you used a gamepad with Unity, and this is implemented automatically when you create UI buttons on a canvas. But a more popular and user-friendly option is to use pointers. Pointers behave like laser pointers, which you can point out of your hands at buttons and select them and select different things in the scene. And they're more complicated to implement because you have to process the user input and also program your buttons to react to the pointers. So it's a little more difficult, but it's much more user-friendly and more intuitive, and anyone who's played a VR game will know how to use the pointers automatically. To help make this be less complicated, we've included some tutorials that are really good off YouTube. There's 2 parts on how to have VR pointers, so that when you want them to be enabled, you have a laser coming out of your hand, and how to do raycasting out of that point to see what they're pointing at. There's also a 2-part tutorial on having pointer enabled menus, so that much like in Unity, when you hover your mouse over a button, it changes color, and when you click it, it changes color. That's done automatically for you. If you follow these tutorials, that will also work for when you hover your pointer over the buttons, and when you select them with the pointer, it will be called automatically, and everything will be working really well. So these are the recommended tutorials if you need that for your game, which you likely will. Also, the channel these tutorials are on have lots of other beginner VR content that you may find useful. So that covers all of our further steps for setting up the scene and development tips and solution to common problems that you may find. And that concludes our VR tutorial.